Hey everyone, welcome back. So today we are going to discuss another LeetCode problem statement, that is find peak element. It's a LeetCode 162 of medium category. So in this problem statement, you have given a integer array and you have to find the peak element, and we just have to return its index. So if the array contains multiple peak elements, then we have to return any one of the index. So what is peak element? So any element which is greater than its neighbor. For an example, here you can see this 3 is greater than 2 as well as 1. So you just have to return its index, that is 2. In another example, you can see we have this index 0, 1, 2, 3, and it will go up to the length minus 1. If you will see, this is the element which is having index 1 is greater than its neighbor, correct? Along with that, we have one more element which is greater than its neighbors. So we have two peak elements. The first index is 1 and the other index is 5. So what you have to do, you just have to return any one of them, either 1 or 5. So it will accept any one of them. Also, we have to make sure that the algorithm that we will write, that should run in O of log n time complexity. So let me quickly jump to the board and we will discuss the approach which we have to follow here. So in this problem statement, whatever array we have given, right? So that is 1, 2, 3 and 1. Index starts from 0, 1, 2 and 3. So there is two approach. The first approach is linear search. In that, what we will do, we will simply iterate one by one and we will try to figure it out, like any element which is greater than its previous as well as next. But for this, the time complexity will be O of n. Now another one is like we have binary search. So we are going to use this binary search algorithm. As we know, like in binary search, we have to calculate start, end as well as mid. One thing is clear, like the array is not sorted order. So for an example, if you are at this position, right? So the element is 2, which is less than 3. It means for sure this is not your peak element. So you have to move forward. If you are at this position and if you will see like whether this previous element is greater, then for sure this is not a peak element, so you have to move backward. Okay, so for that, this will be our start and this will be our end. Now we have to calculate mid. The iteration will move until the start value is less than end value. Okay, now you have to calculate the mid. As we know, the mid formula is start plus end minus start by 2. Now value of start is 0, the value of end is 3. So 3 minus 0, it will be 3 by 2. So you will get 1. So this is your mid. Okay. Now what you have to check, whether this element is less than this. If it is less than the next element, then what we have to do, we just have to simply move the s, it means start, mid plus 1. So start will come at this position. Okay, now again what you have to do, again you have to calculate mid. So the moment start and end is equal to same, right, it means you have found your mid position and you have to return either start or end, any one is fine. In the very next step, again you have to calculate the value of mid. So in this case, the mid value will be start plus n minus start by 2. So you will get 2. You know how? Start value is 2, end minus start means 3 minus 2, that will be 1 by 2. So this will be 0 and here you have 2. So this will be your mid value. Okay, this is gone. Now what you have to check, whether this element, mid element, is less than the previous one. No, in that case what will happen, end will move and it will directly come to this mid. If start has to move, then it will go mid plus 1. If end will move, then it will come at mid. And at last, you just have to return either start or end. Either of them is fine. So that will be your answer. So in this case, this 2 will be our answer. Let me quickly jump and will write the code for the same. Okay, as we have discussed, the first thing we need is start, that will be 0. Another thing we need, that will be end, that is the last index. So length minus 1. This will keep on moving until the start value is less than end. Okay, now you have to calculate the mid. As we know the formula, that is start end minus start by 2. Perfect. Now you have to check whether this, whatever value you have right at mid position, if it is less than the, its neighbor right side, that will be nums of mid plus 1. In that case, what you have to do, you just have to move your start by mid plus 1. Or else what we have to do, whatever end value we have right, that will move directly to the mid. And at last we just have to simply return this particular start value. So let me quickly execute this code and we'll see whether it's working properly or not. Okay, so both the test cases accepted successfully. Let me submit this solution. Okay, so all the 71 test cases passed successfully, and this is the approach we have to follow in order to solve this problem statement. If you like the video, do subscribe the channel. Thank you for watching. Enjoy your day.